Hi everyone, and welcome back to the Game Development Theory. Today we're going to look at how heuristics affect the state of play and some examples of how it works and how to best understand it. If you remember last time we finished on a question, and that question was, how does heuristics affect a random number guessing game? Now, we know there's two ways of looking at heuristics looking at the moment, which is positional heuristics, which is stating who is winning, who's losing, and what the order of winners and losers are, and directional heuristics, which states the strategy you should follow to make sure that you are doing as best as you can. Now, a random number guessing game, so say we just literally had a random number generated between 1 and a million, and you'd guess the number, and whoever gets closest wins. Well, that doesn't really have heuristics, certainly in a directional form, because if it's just random, there's no particular strategy, because if it's entirely random, there's no way of knowing what the number will be. It is just a random guess each time. And if it's just a one-off game, then you can't really state who's winning at any time, because it's just completely random unless you're tallying up or something to that effect. So we should be able to see that a random number guessing game has positional heuristics if you're sort of tallying up your points, but more importantly, it doesn't have directional heuristics. There's no strategy at all. So it's effectively an unsatisfying game because it has bad heuristics in that count. Okay, I'm sure you worked that out for yourself, but just in case you didn't, there's a little explanation for you. So let's look at some examples of heuristics and how they can change given on what a game is. So here's one example. I got it straight from a book called Characteristics of Games by, what's the name? Elias, Garfield and Gutscherer. Now, they've invented these two games to give some examples of heuristics. The first one's called Money in the Bag. You've got two buttons, and you take turns, and every single turn, you have a percentage chance to get a coin. If you press the red button, you've got 80% chance to get a coin. If you press the blue button, you've got 20% chance to get a coin. And every player has their own bag, and they press either red or blue each turn, and you try and get the most coins. So here we should be able to see there's quite clear sort of matches to the heuristics we're talking about. Just take a second, see if you can work it out. So positional, who's winning, and directional, what strategy you should use. Okay, so hopefully you realised that the directional heuristics are very clear. There's a very obvious strategy here. The red button is going to get you a coin 80% of the time, so don't even bother with the blue. Your strategy is press red all the time. However, positional heuristics, the money is in the bag for each player, so no one can really keep track of who has the most money up until you count it at the end and work out who wins. So strategy is very obvious, but actual positioning within the ranks is much trickier. Let's change it slightly and see what happens. So this is money on the table. Things have changed very slightly. Now, instead of putting the money in the bag, we now put the money on the table in front of everyone. Red now gets 50% to get a coin, and blue is 51% to get a coin. Well, this time everything's switched over. The positional heuristics, we can see, are very obvious. Everyone's money is on the table in front of them, so at any point you can see exactly who's winning rather than it being obscured by a bag. However, the strategy is much harder to notice, so in the first game you very quickly realise, probability would dictate that you'd very quickly realise the red button is the best one. Here, blue is better, but only by 1%, which is rather insignificant. So both red and blue, given if you're only playing 10 rounds or so, will probably give you the same amount of coins. So we can see that directional heuristics, there's not as much strategy here. There's a very, very limited amount of strategy, if anything. But positionally, we can see it's very obvious. We can see who's winning. So two examples to show you how positional and directional heuristics can be found. Now, one of the key things to remember that heuristics is not physical skill. You're not, though there might be some good strategies, your actual physical skill, if required, is not going to be a part of the heuristics. So if you're playing something like squash, Squash, you have to hit the ball back against the wall, has to bounce, and then it gets hit back against the wall, has to bounce. Though the best place to be, the best strategy, is to stand in the centre of the court, the tee they call it, and keep hitting this ball from the sort of better positioning. The physical skill required is not the heuristics. Heuristics is picking up the strategy, which is standing in the middle. Your physical skill then works from there. Okay, so don't get the two mixed up. And heuristics and fun are very much so required, because a game is fun because of competition, because of using your brain and working out strategies. I mean, there's lots and lots of reasons, but we can see that those two are rather high up in sort of enjoyment of a game, competition and sort of actually problem solving. So if you are winning and you're using good strategies, you're enjoying a game, and therefore the game has good heuristics because you could actually find you are winning and that you have found good strategies, therefore it can be fun. Heuristics is very, very important in that regard. Okay, so short and sweet this time. Have a try at this. So what I'd like you to do is give an example of a game with good positional and directional heuristics, so it works on both counts, and bad positional and bad directional heuristics, and try and explain why they are good or bad. Okay, next time we'll be talking about different types of heuristics and how they can affect a game and make it satisfying or less satisfying, but for now you've got something to try, and hopefully you're starting to understand how heuristics works by now. Alrighty, see you next time.